What's good, Logan? Gonna try to hit you guys up with another factoring video here. This is just basic factoring, some things that we talked about in class. Might be helpful for tonight's homework. Uh, let's see what we can do. We're gonna focus on GCF, quadratic, and then special types of binomial type factoring. So we're gonna start off with question number one. We're gonna try to hit up all three of these guys and see if we can do it in a timely fashion. All right, so we got 6w to the power 7 plus 11w to the power 6. So far they got w's in common, but nothing else. 6 and 11 are relatively prime. Therefore, I'm not going to even check to see if the 10 can divide anything because the 6 and the 11 had nothing in common. I noticed that we could take out 5w, so I'm going to go w to the power of 5, and that's going to leave us with 6w squared plus 11w minus 10. All right. Next, we have a quadratic. We can tell it's quadratic. It's got three terms, ax squared plus bx plus c. So now I'm going to factor the 6w squared. We got 6w times w. We also have 3w times 2w. I'm also going to do the same exact thing, except this time I'm going to put heavy focus on the backside. So we got 10 times 1, and we got 5 times 2. Our job now is to figure out which of those factors makes the most sense for this problem. So we set up our two binomials, and we either pick 6w, 1w, or 2w, 3w. I am going to pick 3w, 2w. It's just my first choice. I'm going to try that guy, see if that works. If not, then I'm going to try the 6w, 1w. And I'm also going to try the 2 and the 5. So I'm going to put a 2 over here and a 5 over here and see if this multiplies out. This is going to be 4w, and this come here, this 15w. We need those to subtract, and when we subtract these two values, we will get an 11w right there, and that's how we know we're using the right factors. So I'm going to just go back, erase that because I don't need it, and then I'm going to write in, we need a negative 15. No, we need a positive 15 to get that positive 11, but we don't want too much, so we got to put a negative on the 2, and then we're going to go w to the power of 5 on the outside. We'll notice that this is a linear and this is a linear. That means no exponents to it, so no powers on those. And that right there is our final factored form for this polynomial. All right, let's try it again. This time we're going to check number 2. So we'll get rid of this guy here, and we'll factor 20x to the power of 10. So I'm going to write that down, 20x to the power of 10 plus 540. And right away, I notice that they both have divisibility by 10 because they both end in 0. Also, you can take out two x's. So I'm going to go ahead and take out two x's, actually 7 x's. Wow. So we'll take out 7 x's for sure. And I'm pretty sure 540 can be divided by 20. So I'm going to take out 20x to the 7th. This will leave us with 1x to the power of 3, or just x to the power of 3, plus, now 540 divided by 20 is 27. So we have x to the power of 3 plus 27. The next thing I need to do now is figure out what I'm dealing with. This is not a quadratic. This is something I am not used to. It's fairly new to the Algebra 2 curriculum, so I'm like, okay, so I got to deal with that, and it looks really close to this guy. So this looks really close to this one, not this one there. Some of you are like, why not this one? This one has a minus sign, and that guy has a plus sign, so I'm not thinking they go together. What I need to figure out is what are the things that are multiplied together 3 times to get that a, and that's going to be x times x times x. And to get that b, that's a weird one. It's actually a number, so it's 3. So what we have here is we have an x times x times x, and then a 3 times 3. So in our brain, we're going to be thinking that's 3 to the power of 3, and this guy's x to the power of x. Now, I'll often refer, not x to the power of x, sorry, x to the power of 3. I'll often refer to this as the a, and I'll refer to this as the b. And you'll notice in the formula we want to make sure that we go with 1a, 1b, and then we're going to go 2 a's, or a squared, so a times a, and then a times b, and then b times b. So it's an a and a b, an a times an a times a b, and then a b times a b. So let's go ahead and try and write this guy out. So we're going to go an a and a b, so an x and a 3, and then we're going to go an a times an a, which is x squared, and then we're going to go an a times an b, so that'll be 3x, but it's a minus in this formula, and then it'll be a b times a b, which is plus 9. And then we have the original GCF, 20x to the power of 7. This is a linear. This is a quadratic, but it's an unfactorable quadratic. I know this because I've done it quite a few times, and anytime, in my class at least, when you're dealing with the cube types, when they give you quadratics at the end, those will be unfactorable. So you're not going to have to worry about factoring those quadratics further. All right, there's our answer for question number 2. Okay, let's see if we can jam through question number 3. to make more sense out of these factoring type problems. Remember, if you don't get it, you can always stop, pause, rewind, and get the information you need. All right, so number 3, we got 5r to the power of 3 minus 605r. Noticing right away for myself, they can be divided by 5. They also have an r in common. So I'm going to go ahead and factor out the r that they have in common, and then I'm going to divide by 5. So I'm going to factor out the GCF of 5. This is pretty nice. We get r squared in the front. But 605, that's kind of weird. 5 goes into 6 one time with a remainder of 1. 6, and then 5 goes into 10 2 times with no remainders. And then 5 goes into itself 1 time. So I get r squared minus 121. This is looking super, super familiar. Algebra 1, where you got the a squared minus b squared. So we're going to be looking at a and b's, and then the way it works is when you're factoring an a squared minus b squared, we just need an a plus the b, and then a 1a minus 1 of the b's. So there's no multiplying of the a's or b's together. All right, so we're just going to factor this guy out. So we need an a plus a b. That'll be an r, because a was r, and then b is 11, so we're going to go in a plus a b, so 1r plus 111, and then we need another r minus one of the b's, and 1 minus 1 of the 11, so we got r minus 11, and then we have the 5r in the front. And once again, since that's linear, they're all linear, we know that this is now done, it's unfactorable, and we factored all 3 of these problems. If you have any questions, please come back to class tomorrow, hit me up, or send me an email, and I'll help you as much as we can. Other than that, I'll see you guys in class. Peace.